Do you recall the constituent gases of the atmosphere from the first section? I'm going to remind you. Nitrogen, which is 78%. Oxygen, the O2 version, which is 21%. Argon at 0.9%. Carbon dioxide at 0.04%. And other at 0.06%. It's now time for us to take a closer look at that 0.06%, the other. We now know that water comes in the three states of matter: solid, liquid, gas. Gas and vapor are interchangeable terms. They're synonyms. Atmospheric water is a variable gas. What that means is exactly what it sounds like it means. It varies. It's not always the same every place. It can vary from as little as 0% of the atmosphere, which means absolutely bone dry air, to as much as 4% of the atmosphere, which would be absolutely soaking wet air. But its average, like carbon dioxide, is about 0.04%. Where is it likely to be near 0%? And where is it likely to be near 4%? I'm going to tell you something. When I taught in Illinois in the early 1990s, coming from California, although my family's from Buffalo and I'd been around snow plenty of times, I'd never spent a winter in that kind of weather. People used to say, it's too cold to snow. And even with what I did, I was like, what? Are you crazy? It's too cold to snow. What does that mean? Well, it means exactly that. Sometimes it can be too cold to snow. This also means that the place where we're likely to hit 0% is in very, very cold air, someplace like Antarctica. And the place you're likely to get 4% is going to be very warm air with a lot of vegetation. A place like, for example, the Amazon might fit this. Let's take a look at the lowly sponge. Take a look at it. Sponge is looking back at you. If I took a dry sponge and I set it in a pan of water, what is it going to begin to do? Good. It's going to begin to absorb water. How much water is it going to absorb? Can I just tell you something? I have never had a class in more than 30 years of doing this not be able to answer this question. So one of you better be able to answer it. How much water is it going to suck into itself? The answer is it's going to keep pulling water in until it's full. Good. The atmosphere works in a very similar way to that. Given the opportunity to absorb water, the air will absorb water. If I poured a glass of water out on a table and came back in 5 or 6 hours, it's gone. Where did it go? It didn't soak into the table. It was evaporated into the atmosphere. So we are talking about atmospheric water. There are two rules related to atmospheric water. The first one is in this video. The second one comes in another video. The first one I'm calling rule number 1. Rule number 1 is this: the warmer the air, the greater the amount of water vapor it can hold. And the colder the air, the less water vapor it can hold. Temperature then is the key to how much water the air can hold. And it works like this. With warm air, the potential capacity to hold water vapor increases. And with cold air, the potential capacity to hold water vapor decreases. I'm saying potential because we don't know how much it's holding. I'm just telling you how much it could hold. That is the potential. Take a look at this. 2 glasses. 2 households, both alike in dignity, in fair Verona, where we lay our scene. From ancient grudge break to new mutiny, where civil blood makes civil hands unclean. Oh, sorry, I digress. 2 glasses. Take a look at these 2 glasses. Are they the same size? No, which means they can hold different amounts of water, correct? The glass on the left is a 12-ounce glass. The glass on the right is a 16-ounce glass. Let's talk about potential capacity. What is the potential capacity of a 12-ounce glass to hold water? Of course, the answer is it can hold 12 ounces. That's it. What is the potential capacity of a 16-ounce glass to hold water? That's correct. It can hold 16 ounces of water. That's its potential capacity. This is what I'm talking about. I don't know whether either of those glasses have any water in them, but their potential is 12 ounces and 16 ounces respectively. What happens if you try to pour the 12 ounces of water, if the glass is full, into a 16-ounce glass? The 12-ounce glass was filled if it had 12 ounces of water, but when you pour that into a 16-ounce glass, is the 16-ounce glass full? No, it's 75% full. Even though one of these two glasses was completely full, the 12 ounce, when it had 12 ounces of water, the 16-ounce glass, if you put those same 12 ounces in, will not be full. Now what happens if you try to pour 16 ounces of water into a 12-ounce glass? Well, once it hits 12 ounces, the other 4 ounces of water are going to pour out all over the place. The atmosphere is going to work just like that. When the atmosphere is full, water is going to come out. What form that takes, we don't know that yet. We're still getting to that place. But it's going to take some form. Once the atmosphere is full, water will begin to come out. If the 16-ounce glass is holding 16 ounces of water, how full would we describe that, expressed as a percentage? You had a 16-ounce glass with 16 ounces of water. How full is it going to be? Answer is 100%, right? That's what the answer is. And if the 12-ounce glass has 12 ounces of water in it, how full is it? It's 100%. So both of these things can be 100%, even though they're holding different amounts of water. The atmosphere, again, works in a very similar way back to the two glasses. Let's assume the blue lines on the glasses indicate where the water level is at in the glasses. On the left-hand side, we have a 12-ounce glass. How full is it? On the right-hand side, we have a 16-ounce glass. How full is that one? Well, the answer is they're both 50% full. This is the way we want to express it. We don't want to express it as half full or 3/4 full. We want to express this as a percentage. And if we're expressing it as a percentage, it would be 50% full. So with the 12-ounce glass, how much water is in the glass if it's half full? Come on, do the math with me. 6 ounces. Very good. And with the 16-ounce glass, how much water is in that 16-ounce glass if it is half full? The answer is 8 ounces. You can do this. Now take a look at these same glasses. There's the 12-ounce glass. How full is that glass now? And look at the 16-ounce glass. How full is that glass now? Take a look. Take a good guess. I'm going to say 75%. Okay? So what do we have? We've got a 12-ounce glass that's 75% full. We've got a 16-ounce glass that's 75% full. Let's see if we can do this more complicated math. If you have a 12-ounce glass that's 75% full, how much water is it holding? Answer is 9 ounces. If you have a 16-ounce glass and it's 75% full, how much water is it holding? Answer is 2 ounces, 9 ounces, 12 ounces. Okay, this would be the answer. So how much water is a 12-ounce glass holding? 9 ounces if it's 75% full. How much water is a 16-ounce glass holding if it's 75% full? 12 ounces. I think you can do that. If you can do this part, we can now take the jump to the bigger, more complicated concepts related to this. But remember, just be looking at the glasses as if they are the atmosphere. That's the analogy or the metaphor.